Hi children, today's class is about parabola. What is a parabola? Normally what happens when I introduce a topic of quadratic and we talk about the graph of polynomials, we mention a word over there, parabola. Now many of the inquisitive minds, they keep asking me, what is a parabola? Now here, to begin with what a parabola is, first we talk about a circle. So I'm producing a circle. So there is a circle here. We know that the center of the circle is somewhere near my origin. I mark it as a point A and I pick up any point B which is lying on a circle. Now how many of you we know how to define circles? Now, when I'm going to define a circle, I would say always that this point B and this point A will always be equidistant, no matter wherever I locate a point on a circle. Now, that is a closer definition of a circle, and that is how we define a circle. It is a locus of points or the path followed by points such that they are equidistant from a fixed point. That fixed point is my center. I'm repeating. So it is what? It is locus of points equidistant, equidistant from a fixed point. Okay? They are equidistant from fixed point. All the points which are equidistant from a fixed point. Okay, should I remove these lines? Okay, good. So they are equidistant. What is that equidistant? That equidistant thing, I know it is my radius. We normally represent it by a small letter r. And that fixed point is, I know it is the center of my circle. Right? This is what a circle is. This is how I define it to be a circle. So if I move this point B anywhere on my circle, right, the distance between point A and B will always be same. And how can I show it to you? I can draw a segment from B to A, okay, and that is the segment F. You can see an F over there, and that F for my circle is equal to 3. Now what happens if I move this point B around on the circle? My F is always same. Got it? Now we are going to switch on to what we call as parabola. This is something which we all know. So I will say clear all my drawings, hide my center, hide my point, hide my radius, hide my circle. Now I want to show you a parabola. That is my parabola. If I pick up any point which is lying on parabola, this point C is lying on my parabola. So it can move. I can make the screen smaller so you can see a bigger version of my parabola, how my parabola looks. Now this is just one parabola. You can have 4 parabolas. You can have a parabola like this. You can have a parabola like this, and so on. So this is any point on my parabola. Okay. Now what happens if the, right, so what the story says is that if I have a parabola, can I move this thing? Just move it over here. Okay. So when I have any point on my parabola, let this be a point C. Can I just fix this object? Fix it. Okay. Okay. So when I have this point C for me, I need to think of a particular line. Let me say some line which is x equal to -1, such that the distance of the point C from this line, how do I find a distance of any point from a line? If I need to find the distance of any point from a line, I'm going to draw the perpendicular. So perpendicular which passes through C, and it is to this line. That is my line. Okay, so this line will give me how far my point is from this particular line. You getting my point? How far my point C is from this line. It's looking very weird, so I can do one thing. I can just make this line kind of not visible to you, or I can say I can go on to the properties of this line and make it dotted for you. I can change the color. So this is my distance. So this pink line is giving me the distance of my point. Right now, wherever I move my point C, this length CD, right? So let's give a name to this length. Let's name it by some segment. So this length CD, which is H for me, right? It is going to give me the distance between this point C and the perpendicular to the line. So this is H. So wherever I move my C point, H will keep changing. Can you see? So H is changing. So H is the distance between the point C and there is a line over here, some particular line. Okay, I'm going to give a name to that line. So I'm going to call this particular line as directrix. Okay, so this line is called as directrix. Okay, and I'm going to give a name to a point which is somewhere on my x-axis, and I'm going to call it as a focus over here. So that point will be focus. Getting it? Suppose if I say that there is some point which is lying over here, let me call that point to be E point. Okay, so there is a point E on my x-axis. When I draw a segment between E and C, okay, and it's having a name I, this particular line, it is distance of my point C from my focus. So there is a point E which is surely my focus. So this focus is for E point, C is my any point. Now what I'm going to observe is that H and I, where H is depicting the distance of C from my directrix. Are you getting it? So it is the distance of my point C from my directrix. And what about my I? I is the distance of the point from my focus. So these H and I values, you will observe they will not change. Wherever I'm moving my point C, I can keep moving. Yeah, I can keep moving. But wherever I move, this distance is not changing. So that is the definition of a parabola. No matter where my point C goes, but its distance is constant. Its distance is constant. Where constant, I mean it is same when I measure it from a particular line that I call as directrix and a particular point that I call a focus. So all such points are going to follow a particular path. And what is the name of that path? That path is said to be a parabolic path. If you want to continue, I'm going to upload a second video in that, which probably will take down to your grade 11. Right? So it's going to follow a parabolic path. It's not that you're not connected to a parabola, you have been connected. Do you remember you did free fall of bodies? Free fall of bodies, that's an experiment Galileo performed. So that path which the bodies follow is a parabolic path. That path which bodies follow is a parabolic path. So that is a parabola. That is the definition, mathematical definition of a parabola. So we'll stop here for today.